Welcome. Lecture number 34. Parallel forces we are continuing. One small information. Not information actually. I want to tell something. Engineering mechanics. Many people are not watching fully. Maybe they are thinking, these are all not required. Don't have that feeling. These are all basic concepts. Once the basic concepts are clear, then only your structural knowledge will improve. Do not think suddenly you can go to strength of materials, we'll learn from there. No. Lot of doubts will come there. Engineering mechanics is a full basic. So once you understand everything from here, it will help you a lot when you go for higher part. So still it is left to you. Okay, now make a note here. Question number 2, last time I solved question number 1. It was resultant for parallel force system. Remember, I considered unlike parallel force system. Systematically, if you want to solve, first you should solve like parallel force system, easier than unlike. I am not doing unsystematically like that, but I feel like parallel force system, I don't have to explain much. If I take unlike first and explain thoroughly, like becomes more easier. So therefore, last time I solved one unlike parallel force system. We will solve more questions on that one. Now before proceeding further, question 2, find the resultant for given parallel force system completely. See, parallel force system, all are downwards. So this is like parallel force system. One more question is here. See, here forces are vertical, here forces are horizontal. One more I will give when the forces are inclined. 3 like system I will give first. But remember one important concept. Already we solved for unlike parallel force system. I explained each and everything last time. Therefore this time for this question I will not explain much. So class, it is somewhat like a homework for you or exercise. Very briefly, nobody can tell. Sir, unlike I can solve, like I cannot solve. It is very odd. So therefore, remember question 2 class means very brief solution. See, write a note here. What all I told last time, how I solved last time, what statement I given, you should write for this question also. Okay. Class, I will dictate here. Parallel force system. And fortunately, like all are same direction. Therefore, very easy. Resultant equal to 250 Newton down. Why? 60, 40, 80, 70. Yes, over. No further explanation. Someone will tell, he directly told the answer without explaining. Go to last time question. Tough question. Tough means unlike it was, but this time like. Okay, now. Line of action of R will be where? See correctly. Solve same as last time. Do one thing. See. Do one thing now. Don't write in this question. Take a reference line here. Take a reference line here. Mark a point here. Locate resultant R. One more sketch. See how I wrote last time. That way write the sketch. See. To locate resultant. See. I will call this line as AB line. Okay. AB line. AB line. Some point A dash here. So somewhere here. Mark AB line. Any point A dash here. From there, let the resultant be to any side, right side. Pen is not open. It's okay. See. By X. This is resultant R equal to how much? 250 Newton. I am not explaining much because repetition. Okay, start. Apply Verigne's theorem. Clockwise positive. Moments are in Newton and meter. 60 into 0, 40 into 2, 80 into 3 plus 2, 5, 70 into 5 plus 2.5, 7.5 equal to resultant R into X. Also clockwise, you will get X equal to 4.02 meter plus will come. This X will come plus 4.02 meter. Means line of action of resultant we considered from the point A dash to right side. Positive sign came means what you assumed is correct. It is right side. So resultant will be at 4.02 meter from here. This is 2. This is 5. So it will be somewhere here. After 40, The 2.02 more, it will come here. Now, same question, solve once again. What you do? Once again solve. Remove this A dash B. Remove this one. One more sketch. Consider reference line here. You can call AB, okay, CD. CD, take a point C dash here. See, CD. Let the resultant be here. Surely resultant is somewhere here. So, this way take X. X. Now solve. Apply Verigno's theorem. Moment about this point. Clockwise positive. Minus 60 into 7.5, minus 40 into 5.5, minus 80 into 2.5 equal to R into X, but anti-clockwise minus, your X will come, once again it will come plus 3.48 meter. See, same answer. Therefore, right here, line of action of resultant from this line or from C dash, we took to left side by X. Positive came correct, 3.48. See, perfectly tally. Solve the question. Now, solve question 3. This also same as this question. Only change is here forces are vertical, here forces are horizontal. Okay, no problem. See here. 20, 12, 10, 8. Therefore, brief solution. Class, once again brief. Resultant R. I will take right side positive. 20 plus 12 plus 10 plus 8 plus 50 means resultant is 50 Newton right side. Story, statement, all I am not giving now because already told in the first question. Statement, we require magnitude, direction, line of action, everything told. If you don't study the previous class question, then you are losing. See, even if I solve briefly here, you have to, for your benefit or future help, you should make a practice of solving every question with systematic writing. Maybe difficult in the beginning, but once you write, it is a permanent copy for you. People don't understand that one. They will tell, sir, who will write every time? Okay, don't write. Later struggle. Okay, now, see, resultant 50. To locate line of action of resultant R, class, resultant is horizontal. Remember, if there is this also I told you, see, last time resultant was vertical, you require horizontal distance. Now resultant is horizontal, you require vertical distance. Means instead of taking AB line here, you take a AB line somewhere here through the first force. Any force you can take, you take the first force. See, AB line here, point A dash here. Class. Option 1, see, about AB and CD I will tell you first. Right now you take only AB line. Okay. Let resultant R be at Y from AB line, somewhere here. Make a note here. We consider the distance Y for resultant from AB or from A dash, Y downwards, remember. Okay. Apply, to get Y, apply Verigno's theorem. Moment about A dash. Clockwise positive, see, minus 20 into 0, minus 12 into 180. Now moment is in newtons and millimeter. Okay. Minus 12 into 180, minus 10 into 180 plus 150 is 230, correct? 230, correct. Minus 8 into 530 equal to minus resultant 50 into Y, anti-clockwise, so minus R into Y. Your Y will come plus 194 millimeter. Now class, write a note here. We consider resultant from line of action of resultant from the first this force, this point here, or this line, this reference line, to be down by Y. Answer came plus. Positive sign indicates not down and up. It indicates that what way you considered is correct. So our assumption of resultant to be below this line is correct. Therefore, answer. Therefore, last answer. See. Therefore, resultant for given parallel force system, will be as given below. As given below, put a sketch here neatly. First show the force, all the force show here. Space is not there. One force 20 Newton, see, 20 Newton, little down 12 Newton, space is not there. 12 Newton and 180, little further here, of 10 Newton, one more force of 8 Newton. If you want distance wise, it is 180 millimeter. This is 150 millimeter. I want to check the camera once actually. This is 200 millimeter. Let me check the camera once. Am I going beyond the line? No. Correct. Perfect. No problem. Now see here. Now there is no ABCD. We took resultant from this line or this reference one below by y. Y came plus 194. This is 180. So it will be somewhere here. See, space problem here. I will make a little upper side. Space problem 12 Newton. So this is the resultant R equal to 50 Newton. From here it is down by how much? 194 millimeter. If that is 194, you write what is this distance if you want. That distance will be total how much? Total is 200, 350, 450, 530. 530 total. 530 minus 194 is 336 millimeter from here. Okay, these are from after getting that one, from total you subtract, this will come 336 millimeter. Okay, now do one thing. See, say once again do it. Option 2, start one, don't cut it here. Once again start, option 2. Let line of action of resultant be at y from not AB line, from CD line, from reference axis CD as shown. Okay, see here, you show a CD here. CD, see here, CD mark here. This is, remove this one. This is passing through the last force here. Resultant will taking what? Somewhere here. R equal to 50 Newton. Distance is, see, note now. Now you are considering line of action of resultant to be y above this line. So if you get positive means correct, negative means below. Okay, start. To get y, same thing, moment about C dash. Take a point here, C dash. Moment about C dash. Moment about C dash. Moment will change. How much? See here, moment about this point. Now clockwise positive, 20 into 530 clockwise plus 20 into 530 plus 12 into 350 plus 12 into 350. Y means I can't tell now. It is too late. Somebody may ask you, sir, how you got it? Then you do one thing. Go back to the first class, engineering mechanics. Today's class number, what number? I forgot the number now. 34 or 44. I forgot it now. You study once again come. Or I will tell, first go back to mathematics, high school level mathematics and come back. Sometimes I should be harsh. See, unless you study everything, my class is not ideal for you. 12 into how much I told? 350 plus 10 into 200 plus 10 into 200 plus 8 into 0 equal to resultant into y. But this time, see, resultant into y is clockwise plus. Your y will come. I will calculate y. 336 millimeter. My guaranteed. I am not bothered to check it. I checked correctly first one, 336 millimeter. Right. Therefore, one note you are right. We consider resultant at y above CD line. It came positive means, yes, correct. Above CD means, see, this is 200, further above. But from here to here is 350, little below. Somewhere here is resultant. That is same as last time. This over. Now I will do one thing now. See, now these two questions are over. Unlike, I will do more questions. See, in the notes for like and unlike, I will give one more homework for you. See, in the notes, instead of all down, all up, I will give you. Next, instead of all right, I will give one all left. Next what? See, that's why I told in notes you get much more question. And there, as much as possible, I write explanation because There's a value for the nodes. Now what I will do is, see, I'll tell you what I will do. Closing part of today. Little short class. Parallel force system, we already considered this way. All are vertical. Then we considered all horizontal. I told you, all are upwards, in the nodes I will write, all are left in the nodes. Now, it can be inclined. If it's inclined, see, inclined means what? It's a parallel. Some will tell, if inclined, you require resolution. No, inclined you require resolution only for coplanar force system. But for parallel force system, but of course it's also coplanar, resolution is not required. I will tell you why. Okay, therefore, I will solve this question. See, what I will do, this I will solve in the class, same opposite direction, I will give in the notes, but then I will solve in the class, one this way, one this way, this way. Unlike I will do next time, because there are some discussions are there. Okay, I will make ready. No, not question 2, question 1, question 2, question 3, question 4. I have not removed it, question 4. Okay, question dictated. For the given force system, I am not telling parallel. Find the resultant completely. Means, write magnitude, direction, line of action. First, solution, class. Write what all I dictate now. 100 Newton at 60 degrees. 200 Newton, 60 degrees. 150 Newton, 60 degrees. 175 Newton, 60 degrees. All on this side. Oh, the angle of inclination of all the forces are same. Suppose I take this as the x-axis axis. See, I written here. Suppose I take this as the x-axis axis. Not there. Okay, wait. Okay. If I take this as the reference x-axis axis, each and every force is making same angle. See, therefore, it is a parallel force system. Of course, parallel force system, maybe all forces are vertical. Some up, some down will do, vertical, or all forces are horizontal, or all forces are inclined at the same angle. Yes, therefore, it is a parallel force system. And if you further observe, this way, oh, this way, this way, this way. Not only parallel force system, all of them has got same direction. Next class what I am doing is, two forces I will put other way. See, next class I will put one force this way, another some forces this way. Then I will tell, no doubt, parallel force system, but unlike. That will be next class. First we will do easy one. Okay. So, all forces, let R be the magnitude of the resultant force. All forces are inclined at the same angle with x-axis, 60 degrees. Given force system is a parallel force system. And also, right here, since all have got same direction, it is not only a parallel, it is also like parallel force system. So here, resultant force will also be inclined at same angle as that of the given force system, that is 60 degree with the x-axis this way. Resultant also is this way. See, magnitude R, direction is fixed. So find magnitude of resultant R equal to directly. See, I told resultant R in this direction. No resolution, right here. For parallel force system, if inclined forces are there, if all are the same, see, in case one force angle changes, I will do a question later, then it is not parallel. It will once again go back to coplanar force system. Then directly resultant equal to 100, 200, 150, 175, 625 Newton like this. Now to locate line of action of R. This is very, very important. I will tell now, to locate line of action of resultant, I will do one thing. First do one thing. Name the points here. A, somewhere here, B. So, other points are not required. Take a point here. See, now a line is given. Reference your what? Y, A, B, C, D not required. Point you can mark. Take a point A here, B. Not given the question. Write the sketch once again. Write, see, this sketch you write once again. With name A, B. Okay, now further. If you want to learn everything, write once again. See. See now, next. Let line of action of, I won't waste time, resultant are cut AB line, AB line, okay, AB line at a point X, comma, at small x from A as shown. See correctly now what I am doing, as shown here. Same point A here, same point B here. This total length is not required. See, you can see there. We don't know where. Close your eyes. But same 60-degree angle. Oh, sorry, it should look like parallel. Okay, little out of scale. Okay. Someone says, sir, why so near? Okay, where you want now? You want outside? Okay, I'll tell you. Wherever you want, you can cut. You are not knowing where. See, you are locating that one. See. Resultant R equal to, how much it is? 625 Newton. Now important now, 625 Newton. See, this point is X. From here, horizontally, we take X right side. Okay, now, see here, further. To get X, I write everything this time. Apply Verigne's theorem. Verigne's theorem. Consider moment about any point A. Okay, I will take moment about A. Here, A. Then consider moment about A. Then write here. Then what happens? Algebraic sum, I am writing once, why? Because this time I am writing algebraic sum of moments of given force system about A equal to what? Moment of resultant force R, moment of resultant force R about the same point, about A. If you take moment about A, moment about A only. We will take moment in force in Newton, distance in meter, Newtons and meter. And we will take clockwise positive. Now, one very important concept. See, correctly observe what I am telling. This is one, leave it now. You tell it. Hey, you wait for some time. You tell system, I am coming back to you. Now, don't write here. You write somewhere outside. You write somewhere outside. Outside. What I am dictating now, you write somewhere outside. When you take moment about A, 100 into 0, 200 into this perpendicular distance, 150 into this distance, 175 into this distance equal to resultant R into this distance. So, from the point A, you require perpendicular to each and every inclined force. If you want to avoid it, you have to resolve it. No, none of them required because advantage. Do one thing, see, just consider a force P, inclined force P, consider inclined force P, say at angle theta with xx. Very, very important, see. P. Some point you mark here, any point, see. You want moment about A here. See, don't tell A. Let us find moment about any point. Say, some point, don't see there. This is the point acting here. any point, say A, B, C, C, say C. Okay, this is theta. Write first. Technically, moment equal to force into perpendicular distance. You write here. Actually, moment of the force P about C equal to force P into, you write here, this perpendicular distance. Put one sketch, H. It is P into H. But now you require, now for understanding, let this distance be A, small a, some distance. It is P into H. Therefore, you require the value of H. So you have to go for trigonometry and get it. Okay, but, right, you write the sketch, but see here, but only for parallel force system, you can go very easily because, see, or, but, do one thing, see, I'll write here now, this is the point A, not C, this is the force P, inclined force P at angle theta, this distance is A, we want moment about C, correct? You can do one thing, resolve it, resolve P, then, see here, C at this point, see, I will take the point as D, force P, say at D, resolve the point at D. One component is vertically down, see, vertically down. This will be P sin theta. One component is horizontal. This is P cos theta. This distance is A. Then moment about C equal to P sin theta into A. That's all. That is all. Because P cos theta into 0. Oh, right. Oh, so easy. So you don't have to worry about anything. What you do is, you instead of when you take moment, you don't consider the force P. If it is this type of force, if angle is theta, see, for each and every force, vertical about this point, vertical component will create a moment of just like a, see, vertical force, horizontal distance. That horizontal component will pass through the point A. So make a note here. Therefore, for the present given parallel force system, when you take moment about A, there will be moment about A only for the vertical component of the forces. Horizontal component of the forces will have no moment. So you can do one thing. Every force you take into sin theta, multiply. Even that sin theta also will get cancelled. See there. Even that sin theta also will get cancelled. I will tell you later. Because it comes for resultant also. Write all the statement. Make full clear. Then after all the statement, now see. Direct answer now. See, correct what I am doing now. Start. Left hand side is moment of the given force system about A. See here. 100 this into 0. You don't have to waste time. 100 into 0, you don't have to worry. Then this 200 has got vertical component of 200 sin 60. 200 into sin 60 multiplied by, see, vertical component into horizontal distance 3. That's all. How? See, force is vertically down, clockwise, over. Oh, then so easy. Plus 150 sin 60, 150 into what? Into sin 60 multiplied by 3 plus 2, 5. Plus 175 into 175 sin 60 multiplied by, see, this force into 3 plus 2, 5 plus 4, 9. 9 equal to moment of resultant is 6. Resultant are, see, resultant R into sin theta. See here, resultant R, not sin theta, this angle is 60 degrees, right here. This is 60 degrees, no theta. Resultant R into sin 60 into, see, moment about this point. Resultant R is vertical component into x, clockwise, positive. Other one, R equal to 625 Newton over. Other is 0. Now if you observe, see, this is 0, leave it. Sin 60, sin 60, sin 60, sin 60 cancels. Oh, or make a special note. In future, if all forces are inclined, when you take moment, you don't have to write everywhere sin 60, sin 60, sin 60 like that. You take normal moment. You imagine the force is vertical. 200 into, right here. 2, you write simply next time onwards, see, you write here. 100 into 0, not required, see. 100 into 0, not required, plus 200 into 3, plus clockwise, be careful, plus 150 into 5, plus 175 into what? Into 5 plus 4 is 9. Outside right, sin 60 equal to R into X. R into X. There also, outside right, sin 60. Sin 60 cancels. Or, that is, only for parallel force system, when you want to locate line of action of resultant, you need not resolve. You, even though load is inclined, you solve as if the load is vertical. No problem. You solve. Imagine vertical. Why? Vertical, but technically outside, sin 60 or right. So, but when you want emergency answer, see, you imagine vertical. 200 into 3, 150 into 5, 175 into 9 equal to 625 into x. Everywhere, sin 60 outside, you get x. Make a note. X will come in meter. I have to calculate now. 1 minute. 200 into 3 plus 150 into 5 plus 175 into 9. Answer divided by 625 is 4.68 meter. 4.68 meter plus. Next time, next class question, negative will come. This is initial questions. Negative, I see that x comes negative. 4.68 meter. Right. Therefore, resultant, red color, resultant force for given force system is as shown, as not below, as shown, you write below, I write below here, right, but below there is no space, so he is writing there. Don't put comment on that one. See, this is 1 force here, you write the force, you write it. After 3 meter, second force, forces you write, I have no time to write. After 2 meter, 1 more force, you write the forces. This is 1 more force here, right here. This is A, this is B. 4.68 means this is 3, little more, 4.68. This is 5, so somewhat near to this one. Same angle. See, okay, I will write what is there. 100 Newton. This is 200 Newton. This is 150 Newton. This is 175 Newton. Distance problem is there not, right? Okay, I will do one thing now. This distance you write. Okay. Boring, try distances. Okay, distance you write. No space. If I write distances, there is no, see, if you want distances, I don't know up to where space is there. I should check the board now. I should check the camera. 3 to 4, 3 meter, 2 meter, 4 meter. I have checked the camera now because I have gone too much down. Oh no, it's okay. Now, resultant point, see, 5. When I came this side, the wire pulled the camera. So it is possible that the camera might have got displaced. I will be knowing only later. No, sometime it happened once. After recording is over, when I saw there, camera was fully tilted. Nearly half an hour I wasted. Means my time was wasted. So therefore, see here now. This point. Or one thing, project here. Space is not there. Right here. 1 minute. 4.68 meter, correct? I forgot it. Is it correct? 4.68, correct. Okay. See, from A here, from A point here, is a B point. This is, yes, right side positive, 4.68 meter. If you want, you can tell this distance is from 9, 3 plus 2, 5 plus 4, 9. From 9, subtract 4.68 and write the answer. 4.32 meter. If you want, 4.32 meter. Okay, now do one thing. Now, just for practice, just for practice, from here, once again solve. Let the resultant be at x from B. See, you take the point x here only, but take it as from B. But remember now, from B you are taking resultant to left side, this way by x. Okay, start. Just moment about B. It will change now. See, start, moment about B. Here, moment about B. Once again start. I'll start from here. 17, now clockwise positive. See, all are anti-clockwise now. 175 into 0 plus. Now you can do one thing. You can now go for shortcut. I told you. Now you got a shortcut for you. What you do? Use shortcut. Just now I explain. 175 into 0 plus 150 into 4. Don't take component. Outside you will write. Not plus, sorry. It is minus. Anti-clockwise. Minus 200 into 4 plus 2, 6. Minus 100 into 9. Into 9. Everything right into sin 60 equal to resultant R into x into sin 60. Space required. Equal to resultant R into x into sin 60. Sin 60 cancels, but remember, see here, resultant R, vertical component R into x is anti-clockwise. If you forget this one, question gone. 100% your x will come plus 4.32 meter. My guarantee. But 1 minute now, I am checking because by chance last time, if any calculation mistake is there, I can make out now. I am not doubting about this value. In the class I will tell, it has to come 4.32. Otherwise, teaching I am stopping. But then someone will tell, sir, that value is wrong. Okay, if that value is wrong, correct it. Accordingly correct it. The corrected value should come. That is called calculation mistake, not technical mistake. Okay, I'll start here. Minus will cancel. 150 into 4 plus 200 into 6 plus 100 into 9 divided by, what is the resultant force? Forgot, 625. Okay, resultant is 625. Divided by 625. 4.32 meter. I told it comes. So plus will come. Means what? Why plus will come? Someone will ask in the class, sir, last time you took right side, sir. Yes, you got a plus. This time you took left side, sir. You got plus. I told positive does not means left side, right side. If you get positive, it means what you assumed is correct. We last time from here we took right side, correct, positive came. Now from B you took left side, correct. From here if resultant is on the right side, from here it has to be on the left side. Anyway, one class I am uploading in the YouTube only for clarifying sign convention. Remember, so many online classes everywhere. I have seen even international level also, they make mistake in the signs. Very sorry, I will tell. So many learned people also, they make sometime, no, I am not finding fault, because it is a fact, I have seen it. Some silly mistake they make. So I will upload a class, hope that they will see it and correct it. And they should tell, oh yes, this is a small mistake, but I should not have done it. See, some will tell, I never thought this is wrong. But this new person suddenly found the mistake. But why? Because perfection is important. Okay, 4.8, same answer. Now, thoroughly work out all the questions. Next time I will take questions for last class for parallel pore system. Very interesting class. Some special questions I will solve. Some suddenly I will ask a question with you. People will not answer. Sir, not clear, sir. Yes, I will tell you why not clear. And everywhere so far you got X positive. Next time negative will come, because if the parallel pore system is unlike, you see, if the parallel pore system is like parallel pore system, resultant has to come in between. But if it is unlike, it may come in between, or it may come left side, it may come right side. All that principle I will tell you in the next class. Thank you. We will meet in the next class. Class number I forgot now. While uploading, I will type it. Thank you.